Let's start by learning about L'Hopital's rule and walk through some examples. L'Hopital's rule is a technique used to evaluate limits of indeterminate forms 0 divided by a 0 or infinity divided by infinity. Let's look at what L'Hopital's rule is. Suppose f of x and g of x are differentiable and g prime of x is not equal to 0 near x is equal to a. If the limit of f of x over g of x as x approaches a is equal to 0 over 0 or infinity over infinity, then the limit of f of x over g of x is equal to the limit of f prime of x divided by g prime of x. When you have an indeterminate form 0 over 0 or infinity divided by infinity, the limit is determined not by the function values at the limit point, but by the relative rates of change, that just means the slope or the derivatives of the numerator and denominator near a. One thing important to note is you are taking the derivative of the top function and the derivative of the bottom function, but not using the quotient rule. Let's now walk through some examples so that we can understand how L'Hopital's rule works. We are going to evaluate the following limits. The first limit is the limit of x squared plus x minus 6, all divided by x minus 2 as x approaches 2. The first thing you always want to do when you are evaluating a limit is start by substituting the given value of x, in our case, x is approaching 2, into the expression that you're given. If we substitute x is equal to 2 on the numerator, we get 2 squared, which is 4, plus 2 minus 6, and we divide all of that by 2 minus 2. This is equal to 0 over 0. When we get 0 over 0, we know that we can use L'Hopital's rule. I'm going to put a little LH over here each time I use L'Hopital's rule. L'Hopital's rule tells us that this is equal to the limit as x approaches 2 of the derivative of the numerator, which is 2x plus 1, all divided by the derivative of the denominator, which is 1. Now we go ahead and substitute in that x is 2, and we get 2 times 2 plus 1, all divided by 1, and that gives us an answer of 5. So our limit is equal to 5. Let's now look at our second example. We are given the limit of cosine x minus 1, all divided by x as x approaches 0. We'll start by substituting in that x is equal to 0. So we have cosine of 0 minus 1 all divided by 0. Cosine of 0 is 1, so we have 1 minus 1 over 0, and we get 0 over 0. This means we can use L'Hopital's rule, and this is equal to the limit as x approaches 0. Now we're going to take the derivative of the numerator. The derivative of cosine is minus sine. So we have a minus sine x, and then derivative of 1 is 0. And the derivative of the denominator is the derivative of x, which is just 1. Now we're going to substitute in that x is equal to 0. So this is minus sine of 0. Sine of 0 is just 0, so we get 0. Let's now look at some more examples. Our third example is the limit of e to the x divided by x squared as x approaches infinity. We're going to substitute in that x is infinity, so this gives us e to the infinity, all divided by infinity squared, and this is just infinity divided by infinity. This tells us that we can use L'Hopital's rule, and our limit is the limit as x goes to infinity. Now we're going to take the derivative of the numerator, and that is e to the x, and the derivative of the denominator, which is 2x. And we're going to substitute in that x is equal to infinity, and we again get infinity over infinity. It is not uncommon to have to use L'Hopital's rule more than once. You just keep using it until you finally get an answer that's not infinity over infinity. So let's go ahead and let's apply it again. Now we're going to take the derivative of the numerator and denominator of this function. So this gives us the limit as x goes to infinity, e to the x on the top, and then the derivative of 2x is 2. We substitute in that x is going to infinity, so we get e to the infinity over 2, and this is equal to infinity. When we get a value of infinity, this just tells us if we look back at our original function, e to the x over x squared, this just tells us that e to the x is growing faster than x squared as x goes to infinity. Let's now look at our fourth example. We have the limit of tangent x minus x, all divided by x cubed as x goes to 0. We'll start by substituting in that x is 0. So this is tangent 0 minus 0, all divided by 0 cubed. Tangent of 0 is 0 because tangent x is sine over cosine, and sine is 0, cosine is 1. So this just gives us a value of 0 divided by 0. Now we know that we can use L'Hopital's rule. So we'll put a little LH here, and we're going to take some derivatives. This is the limit as x goes to 0. The derivative of tangent is secant squared x, and then we have a minus 1. And the derivative of the denominator is 3x squared. Let's remind ourselves that secant x is 1 over cosine x, and this tells us that secant of 0 is just 1 over cosine of 0, which is 1. So in our numerator, we have a 1 minus 1, and we have a 0 in our denominator, and we again get 0 over 0. We can now use L'Hopital's rule again, and this is the limit as x goes to 0. When we take the derivative of secant squared, just think of secant squared x as the quantity secant x squared. So we are going to use the power rule. So this is 2 times secant x times the derivative of secant, which is secant x tangent x. And then the derivative of 1 is just 0. And in the denominator, we have 6x. Now, one thing that's really helpful to do when you're using L'Hopital's rule is when you get to a point like this, before you go ahead and substitute in that x is 0, it's really helpful to simplify the function. And that's what we're going to do. We're going to write this as the limit as x goes to 0 of secant squared x tangent x, all divided by 3x. Now we can go ahead and substitute in that x is equal to 0. Secant of 0 is 1. Tangent of 0 is 0. And then we have a 0 on the bottom. So we get 0 over 0. And we get to use L'Hopital's rule again. Let's go ahead and let's do that. This is the limit as x approaches 0. When we take the derivative of the numerator, let's notice that in the numerator we have two functions, secant squared x and tangent x, so we are going to have to use the product rule. We have our first function, secant squared x, times the derivative of the second. The derivative of tangent is secant squared x, plus our second function, which is tangent x, times the derivative of secant squared, which we've already done. That is 2 secant x times secant x tangent x. And all of this gets divided by the derivative of 3x, which is just 3. Now let's go ahead, before we substitute in that x is 0, let's simplify this. This is the limit as x goes to 0. Secant to the 4th x plus 2 secant squared x tangent squared x, all divided by 3. Now let's go ahead and let x be equal to 0. So we have secant of 0, which is 1, plus 2 times secant squared of 0, which is 1, times tangent squared of 0, which is 0, all divided by 3. And this gives us a value of 1/3. So our limit is equal to 1/3.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.